the random variable describing the time to failure. The general definition of failure at a critical location is, we have looked at this type of approach several times in the last couple of weeks, is that there is a safety margin, there is a performance function that exceeds, that goes out of a safe set, which is gamma safe here. And the overbar indicates the complement. So if this happens at that location X, anytime tau during the lifetime between 0 and t, then we would have a failure. Now, since we are talking about components in this lecture, we will suppress the reference to the location and simplify the definition of failure as the safety margin M, which is time dependent, that goes into the unsafe set at any tau between 0 and t. So since the time axis is ordered, such an excursion into the unsafe set would happen for the first time, and because of all the randomness is involved, the first time that such a thing would happen, such an excursion into the unsafe set would happen, would be the random time to failure. So that's how we formally define the random time to failure. And in general, this comes under the class of problems known as first passage problem, and this t, this first passage time, is variously known as time to failure, failure free operating time, lifetime, etc. And for reasons that we have discussed several times, t is a random variable. Now, for structural components and systems, we do not have the ability to observe directly this time to failure in most situations. Rather, we have to take recourse to the capacity demand time approach to formulating and solving the reliability problem. However, if we have access to a large number of mass-produced, identical and relatively inexpensive components, then we could test them under near actual conditions or under accelerated tests under increased stresses, but we would get a large number of test data, time to failure data, and then we could use them to estimate various metrics of this random variable t. So to recap, we do not have a physics-based definition of failure in such situations. So we do not have a capacity demand time sort of formulation. What we have is a phenomenological approach, and we are going to define time to failure by observation, and then we can estimate various metrics from this time to failure, including reliability, hazard function, etc., which we are going to see later in this lecture.